Alright, welcome back to Andy's. This time I've chosen a problem that'll show you some more features, so let's go ahead and get started. The problem says a wheel is rotating counterclockwise at a constant rate of 3 rotations per second. Through what angle does the wheel rotate in 60 seconds? So this is a rotational kinematics problem, and we're going to get started the same way we get started in all of our problems by drawing out the information that we have on the canvas. And I'm going to always start with, or I like to always start with, the axes. So here I've drawn it out, and you'll notice something different already. Instead of just the X and the Y, we have a Z-axis, which is coming out of the screen towards us, which is why we have the shadow here. Andy's already knows that this problem is going to require the Z-axis, so it does that for you. You don't have to think about it. It also enables this button on the side for the Z-axis. You'll be able to use it as you draw your vectors later on. But before we do that, I'm going to draw out the wheel. And I'm going to come over here. We've been given T0 and then T1 is 60 seconds afterwards. So I'm going to go ahead and say T is the duration of time. That's between T0 and T1. And then I can say T equals 60 seconds because that's what I've been given. Alright, now that we've got that on the canvas, we'll look back at the problem. It says we have a rate of 3 rotations per second. So that's angular velocity. And we're going to symbolize this with omega, since that's the conventional character symbolizing angular velocity. So I'm going to come over here and grab the vector tool, but since this is rotational and going around the z-axis, we're going to enable the z-axis. So we can draw it in the z-axis. Alright, so I'm going to bring it up and just drag it out, and you'll see in yellow it says out of. If I come up here, it says into. The shadow is showing that it's coming out. Well, this one, it's going counterclockwise. That means we're going to draw it out of. Now, you'll notice if I use the backslash, it gives me this whole menu. These are all the Greek characters that I can use in Andy's. If I use my mouse, I can hover over, and down here below says type, and it's telling me exactly what the name is of this character that I'm hovering over. So this is beta, alpha, theta, pi. I can also navigate it by using my arrow keys, so I don't even need to use my mouse at all. And I'm going to go down here, and you see I found omega. If I push enter, it'll go ahead and fill it in for me. That's meant to get you going with Greek letters, and then hopefully the idea is that you'll have them memorized after a while and just be able to type them in, and I'll show that in a second. Omega is the angular velocity. And you see, it gave us our omega, rendered it correctly. I'm going to bring this label over here, deselect it. Alright, so next let's look what the problem's asking for. It's asking what angle does a wheel rotate? So I'm going to need to put a theta in, and I'm going to use a vector to do that. So I'm going to go ahead and draw it out from here. Right next to the other one, I'm going to use the backslash again. And this time, instead of arrowing around, I'm just going to type in theta. By pushing spacebar, it closes that help for me. And then I can say is the angular displacement. Now it turned red, and if I'm not sure why it turned red, I can get some help. So I'm going to go ahead and click the question mark down here and see what it says. Do you really want the direction of that vector to be 241 degrees? So obviously my direction is wrong. And actually the real problem here is not just the angle, it's that I've got it on the wrong axis. So if I click on the z-axis, then you'll see it switches it over onto the z-axis for me. And now it's correct. If I click again, it takes it off. And so you can switch vectors between z-axis and non-z-axis, just like that. I'm going to click off, and now we've got this correct. Okay, we still have one part left that we need to take care of, and that's this 3 rotations per second. And that is our angular velocity. So let's go ahead and get an equation. Click down here, and I'm going to write omega equals, we have 3 rotations per second. 1 rotation in radians, if you remember, is 2 pi. So I'm going to say 2 times pi times 3, because we have 3 per second. Now it's radians per second. And that's correct. So now we've used all of the information we've been given in the problem. We've drawn everything out, and we need to start using principles to solve it. So I'm going to come up into physics, choose a principle, and I'm going to look for something that has theta, omega, and time. So if I go into kinematics, then I can select rotational, and then here right at the top is the principle that I'm looking for. It says the average angular velocity equals the angle divided by time. So if I come back here, I can write an equation that'll do that. Solving for theta just makes it so it's theta equals omega times time. Okay, so this hasn't turned green, and the reason is it says I've done it correctly, but I haven't displayed a fundamental vector principle. So the fundamental principle that I'm missing here is in the z-axis, you either have positive or negative values depending on whether it's coming out or going in. And if you remember the right-hand rule, counterclockwise are positive. In order to not make mistakes, it's asking us to go ahead and write that out explicitly. So I'm going to click the equation tool again. This time I'm going to write out theta in the z-axis equals omega in the z times time. That time it turned green. Now I have the z component, and I have to set up an equation. Theta equals theta z. And like I said before, it's positive because of the right-hand rule. So that's why they equate. And then omega equals omega underscore z. Alright, so now that I have those pieces, I am ready to solve. So I'm going to come down here, and I'm going to say theta equals question mark. If I've done it right, yes, gives me the answer. So I'm just going to double click here, double click on these, just copy, click on the answer box, paste it in, and that's one more problem in the books.